In this video, we're going to start talking about something called a ratio, and we're going to talk about how we write ratios, how we simplify ratios, and how we order ratios from least to greatest. So let's start by defining the word ratio. A ratio uses division to compare two quantities. And I'm going to explain that last little part in parentheses in a second. But it uses division to compare two quantities. Now, there are three main ways that this can be written. First, oftentimes they'll say a ratio is A over B. So you can see that this looks directly like a fraction, which it pretty much is. So a ratio can be written like a fraction, A over B, and you'll notice it says B cannot be equal to 0. So that bottom number right there in your fraction cannot be equal to 0. Because if you do that and you try to divide it in your calculator, you'll get an error. The second way that these can commonly be written is using a colon. So they would say A to B. This is saying the same thing as the fraction. It's just written in a slightly different way. And then the other way we can write it is actually writing the word 2 in between as A to B. So you can see here we have three main ways that we write ratios. The first is the fraction, that is the most commonly used way. The second is using the colon, and the third is using the actual word 2. So now we're going to practice writing ratios given a situation. So here we can see Mrs. Conway's swim team has 14 swim meets this year. So there's a total of 14. 8 of these swim meets were home. Find the following rates. So this first rate here in rate A says you want to find the rate of home meets to away meets. So when I look here, I can see that 8 of these swim meets were home. So I know that there are 8 home meets. And then 2 away meets. Well, it doesn't tell me how many away meets there are, but it tells me there are 14 total meets, and there are 8 home, which means that there have to be 6 away meets. So we have 6 away meets. Now here, what you need to note is that the order does in fact matter. So the 8 has to be equal to your A value, because that's first. And the 6 has to be equal to your B value, because that's second. So we can write our ratio in any of the three ways that we listed on the previous slide. We could say 8 to 6. So this is home to away. You can see they give it to you in the instructions. You could also write this as home to away or home to away. So you can write it in any one of those three ways as long as the 8 comes first since it's before the word to, and the 6 comes second. Now in the second part, in part B, we can see that we have the ratio of away meets to all meets. So I know that away meets is 6 and all meets is 14. So again, order matters. So we'll do 6 to 14. That's away to all. Or you could write it using a colon, 6 to 14, or 6 to 14. So either one of those three would work. Then the last one here, we have the ratio of all meets to home meets. So all is 14, and that's first. Home meets are second, and that's 8. So again, the order does in fact matter. So we have all to home. So we have 14 over 8. That's one way we could write it. 14 colon 8 or 14 to 8. So again, you can use any one of these three ways to write it, but the order does matter. That first one that's mentioned needs to come first. Then the word to is where your fraction, your colon, or your word to appear. And then that second number comes second. So now that we know what a ratio is, let's practice simplifying them. And this should be something that is pretty simple to you because you've actually done this quite a bit in pre-algebra class. So here I'm going to start with part C because that's probably the one you already know how to simplify because it looks like a fraction and we've simplified fractions. And as you simplify ratios, all you are looking for is a common factor that both numbers are divisible by. So for example, when I look at 36 and 12, I can see that they are both divisible by 6. So I start by dividing both of them by 6, so I end up with 6 over 2. Then I can see they're both still divisible by a common factor of 2, so I divide them both by 2 to get 3 over 1. So simplifying ratios is essentially the same thing as simplifying fractions. We just need to find common factors between the two numbers until there are no common factors to divide by anymore. So now let's go back to A, and when I look at A, I see 6 and 24. And what I notice here is that I have 6 and 24 are both divisible by 6. So if I divide both by 6, I end up with 1, 2, 4. And if it's a little confusing to look at it that way, you can always turn it into a fraction. So you could turn it into 6 over 24, and then simplify it to 1/4, and then simplify it back to its original ratio type. If I then look at B, again, remember you could turn this into a fraction and then simplify it. But what I do notice about 28 and 21 is they are both divisible by 7. So if I divide them both by 7, I end up with 4 colon 3. So those are my simplified ratios. And again, this works just like simplifying fractions. You're looking for those common factors you can divide both numbers by until they no longer have a common factor in common. So now we're going to use this same type of simplifying thinking to determine whether or not ratios are equivalent. And really all we're going to do is turn these into their simplest form and determine, are they equivalent ratios, yes or no? If they are equivalent, they will simplify to the same fraction, essentially. So here, 15 over 6, I notice that both of these are divisible by 3. So I divide 15 by 3, that's 5. 6 by 3, that is 2. I then look here at 10 over 4. I notice both of these are divisible by 2. So that simplifies to 5 over 2. So these are, in fact, the exact same ratios because they simplify to be the exact same fraction, the exact same number. If I look at this next one here, what I notice is that 35 and 7 are both divisible by 7. So 35 divisible by 7 is 5, and 7 divided by 7 is 1. If I look at this next one, they're both divisible by 5, so I get 1 over 5. While those look similar, 5 and 1/5 are not the exact same ratio. They are not the same. They may contain the same numbers, but they are not the same. So here we can see by our simplifying that these are in fact not equivalent, and as a result are not the same simplified fraction. So now let's look at how we actually order ratios from least to greatest. So here you can see that we have 1, 2, 3, 4, 5 different ratios. And what I notice is that they're written in all different ways. So what I like to do when I first start ordering ratios is I like to go through and I like to put them all in the same form. So I like to start off by saying, okay, I'm going to write them all as fractions to start. Write them all in the same way so I don't get confused. Now, what I notice here is that these fractions are still somewhat difficult to compare because they all have different denominators. So what you could do is rewrite each of these and determine what their common denominator would be for all 5, and then convert them all. That's one thing you could do, which it would take a little while, but you could find a common denominator. However, what I like to do is use my calculator and figure out what each of these is equivalent to, just as a number with a decimal. So if we look at each of these, what we're going to do is we're going to turn it into its decimal equivalent. You might be thinking, how do we do that? But if you have your calculator in front of you, all you really need to do is use division because these fractions are all just division. So if I look at this first one here, I see 209 over 30. So if I take 209 and divide it by 30 on my calculator, I end up with 6.97. So that one's a pretty large number, actually. If I look at the next one, so the second one here of 36 over 9, if I take 36 divided by its denominator of 9, I get 4. If I take this next one here, 47 divided by 12, I end up with 3.92. If I take that next one of 9 divided by 2, in my calculator, I find 4.5. And then that last one of 83 divided by 8, I end up with 10.375. So looking at them as decimals really helps me to see which number is the largest actually and which number is the smallest. So this says to order our ratios from least, which means the smallest number, to greatest, which means the biggest number. So we're going to start with the smallest number, and if I look at my 5 options down here, so I have 1, 2, 3, 4, 5 numbers, my least or my smallest number is right here at 3.92. That's the smallest of the 5 numbers I see on the screen. So what that's telling me is that this ratio right here is first and is the smallest. So I'm going to go back to my original ratios and write, okay, the first one, the smallest ratio, is 47/12. So then I've taken care of that one. And then I look for the next smallest number, and I see that 2 of them contain a 4. So I have to think, okay, which one of these 2 is smaller? Well, the smaller of those 2 would be 4, because 4.5 would be a little bit bigger. So this ratio of 36/9 is second. So that's what I'm going to write next, and I'm just going to separate them by commas. So I have 36/9. So that one's taken care of. I then notice my next smallest is my other number containing a 4, so that's 4.5. So that would make 9:2 my third smallest ratio. So that comes next, 9:2. I can then see that my next smallest would be the 6 right here. So this would be fourth of 209 over 30. And then my largest ratio is down here at the 10, which means that this 83/8 is my largest ratio. So there we have it, all of them in order from least to greatest. So as I said, the easiest way I think to do this is to convert them all into the same ratio type of a fraction, and then divide that fraction out and order those decimal values. So now that we've talked about ratios in general, we're going to start looking at very specific types of rates, and rates involve ratios. So a unit rate, if we define it in our notes, is a rate with a denominator of 1. So essentially what we're going to do is we're going to simplify the 3 fractions below with their units to have a denominator of 1. So if I look at this first one here, I notice that it currently has a denominator of 12. And if I wanted to make it have a denominator of 1, I would need to divide the denominator by 12, because 12 divided by 12 is 1. So if I divide the denominator by 12, I also have to divide the numerator by 12 to keep this fraction consistent. That's basically simplifying our fractions. So if I take $60 divided by 12, I get $5. And if I take 12 people divided by 12, I get 1 person. So in this particular situation, the unit rate, or the situation with a denominator of 1, becomes $5 per 1 person. So you can see how that's a rate. It's comparing 2 quantities there. Then if I look at this next one, I can see that I have 140 words divided by 4 minutes. And again, I remember that a unit rate, think of unit as 1. A unit rate has a denominator of 1, so I need to get a 1 in my denominator. So I divide the denominator by 4 as well as the numerator by 4. So 140, if I use my calculator, divided by 4 is 35. So my numerator becomes 35 words. I want to keep my units there so I remember what this rate represents. And 4 divided by 4 is 1 minute. So whatever this is, a reading rate or a typing rate, it's 35 words per 1 minute. And again, denominator of 1 is what makes this a unit rate because it has a denominator of 1. Then this last one, it contains a decimal, which is sometimes a little weird. But again, it's that same process if I want my denominator to have a denominator of 1. So currently my denominator is 2.5. I'm going to divide by 2.5 in both the denominator and the numerator. So 80 divided by 2.5 is 32. So we end up with 32 ounces. And 2.5 divided by 2.5 is 1 serving. So whatever this is, whatever type of food this is, 32 ounces is the equivalent of 1 serving. So again, unit rate is denominator of 1. So now that we've looked at unit rates, we're now going to look at something called an equivalent rate. An equivalent, you should know, essentially means equal. Sorry, that was bad spelling there. But we have an equal rate. And so we're going to start with situation A, and I think you'll catch on very quickly. So an equivalent rate, we're trying to find something that's equal given the circumstances. So here in this first one, we are taking 12 calls in 1 hour. That's how many calls you're taking at your job, let's say. And we want to figure out if you're taking about 12 calls per hour, if you worked for the entire day straight, did the entire day, didn't take any breaks, how many calls would you take in 1 day? Well, notice here that hours and days are not necessarily equivalent, but we can kind of switch between them. What we know is that there are 24 hours in 1 day. And so what I can do here is I can think, well, to get from 1 hour to 24 hours, I would need to multiply the 1 by 24 in order to make it the equivalent of a day. And remember, if we're going to multiply our denominator by 24, to keep it equivalent or the same, we would need to multiply our numerator by 24. So if I have 1 hour and I'm turning it into 24 hours, I'm multiplying it by 24. And as a result, I take 12 and I do the same. So 12 times 24 gives me 288 calls in 1 day, which remember is the equivalent of 24 hours. So it's just determining that how many calls you have in your new situation of 1 day, and just using what you know about hours and days and their relationship to help you figure that out. If we look down at the next one, what we notice here is it says we have 1,200 students for 30 teachers in the whole building. So this is a pretty big school. We've got 30 teachers with 1,200 students, and we're trying to figure out how many students should maybe be in each homeroom. Well, here I can see I'm taking 30 and I'm turning it into a unit rate with 1. As I do that, I need to divide 30 by 30 to get 1. Which means I also need to do the same thing here with the 1,200. I need to divide it by 30 in order to figure out how many students each teacher will need to take on. So if I take 1,200 divided by 30, I find that I have 40 students per 1 teacher. And notice that in each situation, this also still makes sense. So here, for decreasing the number of teachers, it makes sense that we're dividing those students up evenly and decreasing the number of students so that we're figuring out how many per teacher. Up here in this first example, we took an hour and extended it to a day, which means that we would expect to make more calls in a complete day than we would in just an hour. All right, and this last example here says we travel 25 kilometers in 1 hour. And then I notice I'm trying to figure out how many, this should be kilometers here, sorry for the confusion. How many kilometers do I travel in 1 minute? So I notice here again I have unequal units here, but what I do know is that in 1 hour there are 60 minutes. So that's something I know about the relationship between hours and minutes. Now, I know that I can travel 25 kilometers in an hour, which means in a minute I should ultimately travel less. So here I see I'm going from 60 minutes down to 1 minute, so I'm dividing by 60, which means I'm going to have to take that 25 and divide that by 60 as well. So 25 divided by 60 is 0.41, and then I'll round it to 7 kilometers per 1 minute. Now that might seem a little weird, but if you realistically think of it, you travel 25 kilometers in 1 hour, which means that you're going to travel less than half a kilometer in a minute. That would make sense because an hour is quite a bit longer than a minute. So we have to take those 25 kilometers and divide them evenly among the 60 minutes that we have in that hour to figure out how far we traveled in 1 minute. So all of this is a lot about using your logic and your common sense to figure out how do I make it equivalent to this new situation of 1 day, 1 teacher, or 1 minute. So now let's apply our knowledge of ratios to start analyzing some different situations. So here it says you are at the store to get some soda. Pepsi is on sale for $3.98 for a 12-pack. So that's what I know about Pepsi. Pepsi is on sale $3.98 for 12. Then you have Coca-Cola is on sale for $5.99 for a 20. So we have Coca-Cola on sale for $5.99 for 20. So I have to figure out which one is the better buy, which honestly is a pretty true situation that you run into when you run to the grocery store. So here, what I need to figure out is I need to figure out what is the cost per 1 can in each situation, because that's really what I can compare. So what I'm going to try to figure out is how much it costs for a single can in each situation. And notice that my order here is going to be very important. I want the cost per, that line can mean per can. I don't want the can per dollar. I want the cost per can, how much it costs for each can in each situation. So I'm going to create that ratio. So here I have $3.98 for 12 cans. And what I'm going to do is I'm going to turn this into a unit rate by dividing each of those by 12. So I want the cost per single can. So if I take $3.98 and divide it by 12, I determined that it will cost about 33 cents per 1 can. So that's what Pepsi's deal is. Essentially, if I divide that out, it's 33 cents per 1 can. Now, if I do the same situation for Coca-Cola, I have $5.99 for 20 cans. So again, I'm going to turn each of these into a unit rate and figure out the cost per can. So $5.99 divided by 20. So I get 0.2995, so that's about $0.30 per 1 can. Now, if I think about this, realistically in this situation, would I rather spend 33 cents per can or 30 cents per can? Well, I always like to shop for the best deal, so I would rather spend this 30 cents per can because that's a little bit cheaper. I'm getting a little more soda for my dollar. And as a result, the Coca-Cola is the better buy. So we can use our knowledge now of all different types of rates to determine what's the best deal in a real-world situation. And our last ratio problem for the day. So it says in 1 hour, Club members, or 4 club members, assemble 320 newsletters. What is their assembly rate per person? So what I need to do here is I need to set up a ratio that will allow me to find the assembly rate per person. Now the key here is reading what they asked in this last sentence right here, because that's telling you how to set up your ratio. It's saying assembly rate, so this is assembly per means my fraction line or my ratio line or the colon or the word to person. So the person has to come second. So assembly is this 320 here. We are assembling 320, and we currently have 320 newsletters for 4 people. And I am essentially trying to figure out how many newsletters are being assembled by each person. So what I need to do here is turn this into a unit rate. So we're going to take 320 and divide it by 4, as well as 4 and divide it by 4. So 320 divided by 4 is 80 newsletters, and 4 divided by 4 is 1 person. So I can take the information that I knew and determine that if everyone is dividing up the work equally, there are about 8 newsletters being assembled by each person.